Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, I have this PSAA power supply module. It is providing 56 volt. It is PSAA 30120. It should provide 12 volt. It is providing 57 volt. So we have to modify it. In this modification, we will remove this transformer, SMPS transformer, and then we have to modify the feedback circuit. We can modify any SMPS circuit, but we have to consider something: the power output. Power output for this model is 30 watt. It is 30 watt power supply. If it is 56 volt, 0.54, and if we will convert it to 12 volt, so we can take 2.5 ampere. So if we are taking 56 volt multiplied by 5.54 ampere, so it is 30.24 watt, and if we will convert it to 12, so we can take 2.5 ampere, 30 watt. We cannot increase the current than the rated value. If we will design, or if we will try to take more current by adding some more turns in parallel in the primary, so it will damage the transformer, it will damage the circuit, because the drive circuit is capable to drive only for 30 watt. So we cannot go above 30 watt. So let's start. If you have no good practical experience in power electronics, never try to repair anything. Never do this practice. Our transformer have two connections here. I disconnected the secondary. I removed the secondary points from here. Now I have to remove primary and bias winding. So our connections are free now. Make sure the bobbin connections or transformer connections are free. Just only press from here. So all pins are free. So we remove the transformer. Here we have the secondary output, and here we have primary and auxiliary winding. I removed the insulation. Now I will use this 100 watt tungsten lamp to heat up. We will place it like this to heat up the core. It will take approximately 15 minutes. It is approximately 15 minutes past. Now it is very hot. Don't apply too much force. Move it slowly. Now this piece is separated without any damage. Now separate the bobbin. Move the bobbin in small circular motions and slightly pull it out. So we have to open this winding, secondary winding. So we have to remove this wire. and we have to take special care for the direction because it is flyback transformer. From this point to 1, 2, 3. So this is primary. In insulation, then we have here we have cancellation shield. So this cancellation shield is connected here. Now I removed this cancellation shield. Remove the turns for auxiliary winding. 1, 2, 11, 12, 13. So now we reached at the output winding, secondary winding. Now we have to count the turns from this point. So we have to check the winding direction and we have to count the turns from this point. 1, 2, 3, 9, 10, 15, 22, 23, 28, 29, 30. So we have 30 turns to take 56 volts. We have 56 volts and turns are 30. So 1.86 volt per turn. For 12 volt, 1.866, 6.5 turns for 12 volt. So it is total 56 volt. For 56 volt we have 30 turns. So 1.86 volt per turn. We need 12 volt from this winding. 12, 1.866, 6.4. So we can set 7 turns. If we set 7 multiplied by 1.866, it's about 13 volt. So we will give 7 turns in parallel of this wire and 7. This wire will enough to make 7 turns. We are using 4 wires in parallel. Before this, 1 wire was used for 5.4 ampere. Now we are using 4 wires, 4 strands in parallel, so that it will increase the current, and we are using the same wire that was used to take 56 volt, but now we will take 12 volt and the current will increase. Here we completed the diode side will be connected to the inner side of the transformer, the starting end. We will take approximately 12 volt, so we have to remove this zener, and we will remove these two resistors. Now we installed the transformer, and now I am taking 16 volt. According to our calculation, it should 12 volt, 12 to 13 volt. But now we have to replace these resistors because this resistor network is for 57 volt. So we have to change this resistance. The lower resistance 2.7k, the lower resistance, and upper resistance 10k. So we will connect 10 kilo ohm resistance here and 2.7 kilo ohm here. So our output should 12.4 volt with this combination. This 10 kilo ohm resistance will go to output filter capacitor, that is here, and the second end we will connect to TL431 pin number 1. And we will connect 2.7 kilo ohm resistance from ground line to pin number 1. So it is ground line to pin number 1. We have to make a jumper across this zener diode. We have to bypass it. This 2.7 kilo ohm resistance here, and it is connected to pin number 1. And this one positive output capacitor, this one, and to pin number 1. I installed a jumper across this zener. As per our feedback network, the output should be DC voltage. It should 12 point. So our output should 12.4 volt. It is 12.5. That's nice. 12.5352 volt, that's nice. And we can check the VCC capacitor. It is exactly stable, that's nice. It's working at, without load, it is working at 26 kilohertz green mode frequency. When we will apply load, it will adjust its duty cycle and it will increase its switching frequency. So friends, I hope so this video is informative for you. If it is informative, hit the like button. If you have not subscribed my channel, subscribe it. If you want to watch my videos in future, press bell icon button. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.